Welcome to Brain Vision.
Hey guys, let's do problem 87. In this problem we need to calculate the temperature. We know that for carbon dioxide the molar mass, critical temperature and critical pressure, these are 44, 304, 72.9 respectively. Now we need to calculate what is the number of moles. Let's do that. It is given that the mass of carbon dioxide is 100 pound. We know that number of moles in is equal to mass multiplied by molar mass. Therefore 100 pound multiplied by the molar mass, which is mass divided by number of moles is equal to mass divided by molar mass. Therefore 100 divided by 44 pound mole, or number of moles is equal to 2.270 pound mole. It is given that the pressure is gauge pressure, therefore let's convert it to absolute pressure by adding 14.7 pounds per square inch. Therefore pressure is equal to gauge pressure plus atmospheric pressure 1600 plus 14.7, which gives us 1614.7 PS pressure per square inch. Now we can calculate what is the reduced pressure. The reduced pressure is the given pressure divided by the critical pressure, or 1614.7. Let's convert it to atmospheric pressure. We need to divide it by 14.7, and the reduced and the critical pressure is 72.9. Therefore we get the reduced pressure is 1.51. Now we need to calculate, we know from the law of corresponding states. We know that the reduced volume is equal to the molar volume multiplied by the critical pressure divided by R Tc, the reduced temperature. Again we know that the specific volume is equal to volume divided by number of moles, or the volume given is 10 feet cube, number of moles is 2.72. It is 2.272 pound mole. Therefore the specific volume is 4.401 feet cube per pound mole. Now we can insert all these values here. The critical pressure is 72.9. Atmospheric pressure, gas constant is 0.7302 feet cube. Atmospheric pressure per pound mole Rankine. The temperature given here is 304. The critical temperature is 304.2 Kelvin. Let's convert it to Rankine. And once we do this calculation, we will get the reduced volume as 0.802. Now for the critical pressure of, now the reduced pressure of 1.51 and reduced volume of 0.802, we get the Z factor as 0.84. Now we can use the compressibility factor equation of each state, which is PV is equal to Z in RT. and we can calculate the temperature. Therefore T is equal to PV divided by Z NR. Pressure is 1614.7. Volume is 10 feet cube. Z is 0.84. Gas constant is 2.272 pound mole. The number of moles is 2.272 pound mole, and the gas constant is 0.7302 feet cube atm divided by 1 pound mole Rankine. Now we need to convert atmospheric pressure to the pressure per square inch. Therefore we need to multiply it by 14.7. And once we do this calculation, we will get the temperature is 788 Rankine. Let's convert it to Fahrenheit scale. We got the temperature as 788 Rankine. Now we need to subtract 460 to get it to Fahrenheit. Therefore, the temperature of the gas is 328 degree Fahrenheit.